Hello and welcome to another video of Grokking the Coding interview series. My name is Parth, and in this series, we are going through the breadth first search algorithms. So let's look at connect level order siblings, which is classified as a medium problem. So the problem statement states that given a binary tree, connect each node with its level order successor. The last node of each level should point to a null node. And here we have an example of how the pointers should be aligned in a tree, and we have an idea of how it should be. So essentially, how are we thinking of approaching this problem? What would be an optimal solution? So if you have followed the previous videos, we have gone through the level order successor or level order reversal approach, where we traverse a tree level after level. And in that approach, we keep a track of the current node. If we can use the same approach and keep the track of both the current as well as the previous node, we can set the pointer of the previous node on each iteration to uh, the current node. That would essentially solve the problem at hand. So let's have a look at what has been provided for us, and let's also quickly try to implement a solution here. So we have a class which is uh, tree node. If you see, an additional attribute here is self.next, which will be the pointer we have to update as we go through implementing the algorithm. We also have a print level order. So after we have implemented the pointer, or we have aligned the pointers of the tree, we can use this print function to print the traversal and the output if it is aligned with what we are expecting. So let's quickly try to implement a solution here. And a lot of it will be pretty standard to how we are implementing other algorithms. So if you have not followed the previous videos, I strongly advise to go ahead and have a look. So if root is none, we simply return the root. We want a queue. This will be the queue. We want to append the root here, and we want to iterate through the queue while the queue is empty. We want the previous node. We initialize it to none. We want the level size, which will be the length of the queue so far, and we want to say for in range level size, we get the current node, which will be queue dot pop left. If we want to check if the previous node is not none, if previous node, then we simply say previous node dot next equals to the current node, and at the same moment we go ahead and update the previous node. So what we have done here essentially is we have first we have keeping a track of the previous and the current node. So as long as the previous node is not empty, we update the next pointer of the previous node to the current node. And in order to make sure that we maintain this track of previous and current node as we iterate through the other nodes in the tree, we want to update the previous node to the current node for the next node traversal. And at this point, so another question which we have to address is how are we maintaining this, that the final element of each level should point to a null pointer. So if we have a look here, we see that the next has been initialized to none to start off with. So essentially all the nodes are pointing to a null pointer at the moment. And because we are not updating the final node in the queue uh, as such, it'll keep pointing to none to end of it. So we do not necessarily need to address that case right away. And rest actually remains exactly the same. So if current dot left, we append it into the queue. If current node dot right, and we simply want to return the root at the end of everything. So this actually should work. Let's quickly go ahead through the implementation and see if it makes sense. If the root is none, we simply return the root. We initialize a queue, we append the root, we iterate through it until the queue is empty. We have a previous node which is initialized to none to start off with. We have the level size, which is length of the queue at the moment. We iterate through all the elements for that level. We get the current node. If the previous node was not empty, we update the pointer. We swap the current and the previous nodes. If there is a left subtree for the current node or the left child, we append it. If there is a right child, we append it as well. We return the root. I think this should address the problem which we have at hand. Let's try to run it and see if our implementation is correct. 12, 7, 1, 9, 10, 5, 12, 7, 1, 9, 1, 5. Okay, so it seems like our implementation is correct. Let's quickly speak about the runtime and space complexity for the implementation. We have gone through it a few times now. Traversal, the runtime will be O of n. At max, we are going through all the nodes of the tree. And when it comes to space complexity, we are using a queue. At max, it can have n by 2 elements for the final level of traversal. And again, it would lead to space complexity of O of n. So I hope you found the explanation clear. Please let me know in case I can improve anywhere or if something was not clear. More than happy to answer your questions. Until the next video, have a great day.